Hello students, let us see one compound of nitrogen, that is ammonia. So ammonia is a compound of nitrogen, the formula is NH3. So let us see the preparation. Actually ammonia is found in air and soil. So the presence of ammonia is there in air and soil where it is formed by the decay of nitrogenous organic matter, example urea. So urea is an example of nitrogenous organic matter. On decay or the hydrolysis of urea, it produces ammonia gas. So urea is NH2CONH2. So urea, the formula of urea is NH2CONH2. So on hydrolysis, or we can say the decay of urea produces ammonium carbonate at first, and then it forms ammonia gas, then water and carbon dioxide. So water and carbon dioxide are formed. So ammonia gas, water and carbon dioxide are formed in this case. So this is actually the decay of nitrogenous organic matter. For example, it is urea. So urea, you know, it's a fertilizer. In some soil, urea can be used as a fertilizer where we can smell ammonia. So ammonia gas can be the smell can be detected in some soils where urea is used as a fertilizer. So actually urea on hydrolysis or the decay of urea or nitrogenous organic matter produces ammonia gas. So this is actually the formation of ammonia in air or soil. Then let us see some small scale preparation method. Small scale preparation. So ammonia can be prepared by using some ammonium salts. Ammonium chloride is an example of ammonium salt, and ammonium sulfate, NH4 twice SO4. So SO4, the valency of SO4 is 2. So it is NH4 twice SO4. So ammonium chloride and ammonium sulfate can be used for the preparation of ammonia. So in the first case, we can use calcium hydroxide. In the second case, we can use sodium hydroxide. So using calcium hydroxide and sodium hydroxide with some ammonium salts, we will prepare, or we can prepare, ammonia gas. So in both cases, ammonia gas is formed. Then we can write the byproduct easily. This is calcium chloride will be formed, and obviously water is another byproduct. So in this case also we can write the byproducts easily, since it is sodium sulfate formed. Na2SO4 is the formula of sodium sulfate. Then water is again formed in this case also. So here ammonia is prepared, or it's a small scale preparation. So we need to balance this equation. So it's a small scale preparation from ammonium salts. So from ammonium chloride, calcium hydroxide is used. From ammonium sulfate, sodium hydroxide is used. In both the cases, ammonia is the main product, and the byproducts are, this is calcium chloride will be formed in this case, and water is there. Then sodium sulfate is there. Sodium sulfate and water are the byproducts in the second case. So this is a small scale preparation. Let us see a large scale preparation for ammonia, or that is the industrial method for the preparation of ammonia. So large scale preparation or industrial method of preparation of ammonia. That is actually called Heber process or Heber's process. The process is called a Heber process, where nitrogen and hydrogen react together to form ammonia NH3. So it's a reversible reaction. So we need to balance this equation. So N2 plus 3H2 gives 2NH3. So this is a reaction. It is called a Heber's process. Here we need to use catalyst to be used, and it's a reversible reaction, and here the delta H is a negative value. Delta H will be negative, that is it's an exothermic reaction. So the forward reaction is exothermic in nature. Forward reaction is exothermic. That means heat is produced. So according to Le Chatelier principle, in order to maximize the yield of ammonia, we need to apply high temperature. We need to apply high pressure and low temperature. So in order to maximize the yield of ammonia, we need to apply high pressure and low temperature. So according to Le Chatelier principle, we have studied if you are applying pressure, the system will try to decrease the pressure. If you are lowering the temperature, the system will try to increase the temperature. So low pressure and high temperature is actually supporting the maximization of the yield of ammonia. Since delta H is negative, that is it's an exothermic reaction. So in this case, high pressure and low temperature that is needed according to Le Chatelier principle. So in order to maximize the yield of ammonia, high pressure, low temperature. So these are the important points. So high pressure like 200 atmosphere that is needed. Low temperature means approximately 700 Kelvin or 777 Kelvin. So these are the conditions needed for the preparation of ammonia. So since it's a reversible reaction, we need to apply Le Chatelier principle, and these are the two conditions needed for the maximum yield of ammonia. And also a catalyst is needed. So for the preparation of ammonia, a catalyst is needed. Here there may be iron oxide with K2O and Al2O3. So K2O and Al2O3. So this can be used as a catalyst in this case. And earlier the catalyst is iron and the promoter used is molybdenum. So iron is the catalyst and the promoter is molybdenum in the earlier times. But high pressure, that is 200 atmosphere, and low temperature approximately 700 Kelvin, and the presence of catalyst that is needed for the maximum yield of ammonia. So this is called a Heber's process. So this is the industrial method for the preparation of ammonia. Now let us see the chemical properties of ammonia. Chemical properties of ammonia. So the first one is basicity. So ammonia is basic in nature. We know ammonia is having a pyramidal shape, and there is a lone pair of electron is there. So there is a lone pair of electrons. So the presence of this lone pair of electrons, lone pair, which is available for donation. So it is available for donation. So it acts as a Lewis base. So ammonia is having a lone pair of electrons. So it is available for donation. So it acts as a Lewis base. So for supporting this basicity, let us see some reactions. NH3. So this is having a lone pair of electron which is reacting with HCl acid. It produces NH4Cl. So this is a salt. Then if it is H2SO4, here NH4 twice SO4. So this will be the reaction. So the basicity or how it acts as a Lewis base because of the presence of lone pairs of electrons. So ammonia is having a pyramidal structure. So there are bond pairs of electrons, 3 bond pair and 1 lone pair. So the presence of this lone pair of electrons or the lone pair is available for donation. So because of the presence of lone pairs of electrons, it acts as a Lewis base. So ammonia reacts with acid, produces a salt, and if it is HCl, we will get ammonium chloride. If it is H2SO4, we will get ammonium sulfate. So salts will be formed. So this reaction supports the Lewis basic nature or the basicity of ammonia. Now let us see the second property, that is it's a weak base. It's a weak base. It's a weak base. That means if ammonia dissolved in water produces ammonium hydroxide, NH4OH. So this NH4OH is in the form of NH4 plus and OH minus. So NH4 plus and OH minus, that means release of OH minus, ions are there. That means it acts as a weak base since it produces OH minus ions in solution. So aqueous solution of ammonia or ammonia in water produces ammonium hydroxide. Since it's a hydroxide, it produces OH minus ions in solution. So it acts as a weak base. So this reacts with this ammonium hydroxide reacts with ammonium hydroxide reacts with some metal salts. Actually, ammonia precipitates hydroxides or hydrated oxides. So if we are using ammonia with some metal salt solution that precipitates hydroxides or hydrated oxides. So let us see some examples. That means if we are using ammonia means ammonia in the form of aqueous solution, that is NH4OH itself. We can write NH4OH. If it is zinc sulfate, this is a metal salt solution. So zinc sulfate aqueous, NH4OH aqueous. If you are using zinc sulfate as metal salt, so this form, it is ammonium sulfate will be the byproduct actually, and zinc hydroxide ZnOH twice and NH4 twice SO4, ammonium sulfate will be formed. So zinc sulfate, it is a white PPT. So this is hydroxide. So hydroxide will be formed, or NH3. Here NH3 precipitates hydroxides. That means zinc hydroxide will be formed if you are using zinc sulfate as the metal salt solution. So ammonia is used in the form of aqueous solution, that is NH4OH itself. If ammonia with water form NH4OH, so we can write NH4OH. Zinc sulfate is an example of a metal salt and it produces ammonium sulfate as a byproduct, and zinc hydroxide, that is a hydroxide, will be precipitated out. So this is the reaction where we can see it acts as a weak base. Now let us see another reaction for the formation of hydrated oxides, where FeCl3, another metal salt, is used. So aqueous FeCl3 and again NH4OH aqueous. If it is used, we will get again ammonium chloride will be the byproduct, and here Fe2O3.XH2O. So this will be the precipitate and ammonium chloride will be formed. So ammonium chloride will be the byproduct. Here Fe2O3 is so it's a brown precipitate. So in this case, we can see a white precipitate of hydroxide and a hydrated oxide. It is a brown precipitate. So in these two cases, we can say it acts as a weak base. So ammonia actually precipitates hydroxides and hydrated oxides with some metal salt. So that is the reaction. Now let us see another reaction, that is it acts as a complexing agent. This ammonia acts as a complexing agent. So ammonia as complexing agent. So it forms complex ions. So complex compounds or complex ions are formed by ammonia. That is, this is because ammonia is having a lone pair of electrons. So the presence of lone pair of electrons, the lone pair of electron will help it acts as a complexing agent. So where this lone pair of electrons can be donated to some metal ions and form a complex compound or a complex ion. So let us see some examples. If it is Cu2 plus copper ions, so if it is an aqueous solution of copper salt, so copper salt where Cu2 plus ions are there, if ammonia acts as a complexing agent, this lone pair of electrons can be donated to this metal, and there will be a linkage. A linkage will be there, or a complex ion will be formed. Here Cu NH3 4 times 2 plus. Actually, this will be formed in this case. So this is actually a complex ion, and this is deep blue in color. So deep blue in color. So if you are using aqueous solution of ammonia and aqueous solution of copper salt, we will get a complex ion, or complex compound is formed where we can see a complex ion, and due to the formation of this complex ion, a deep blue color is formed. So due to the characteristic color of the complex, we can use this reaction for the detection of some metals like transition metals. We can say transition metals like copper and silver. So transition metals can be detected by using ammonia, aqueous ammonia. Since it is having a lone pair of electrons, those lone pair of electrons can be donated to the metal ion and there will be a linkage is formed, or it acts as a complexing agent and a complex compound is formed where we can see a complex ion. So due to the formation of complex ion, the characteristic color is formed. So due to the formation of a characteristic color, we can identify or detect the presence of a particular metal like transition metals. So this is one example where NH3 as a complexing agent. Then another reaction is with silver ions. So another transition metal, that is silver. So here also we can use silver compound if it is Ag plus aqueous and Cl minus aqueous. First of all, it reacts together to form AgCl salt. AgCl which is a solid, AgCl solid. So this is a white PPT. This is a white PPT. So if you are using this white PPT with aqueous ammonia, again there is a complex compound is formed. So this is actually the complex compound. Here it is colorless in nature, it is colorless. So if we are getting a colorless solution, we can say, or we can detect the presence of Ag plus ion, which is a transition metal. So here the presence of lone pairs of electrons help to link with the metal ion. So the lone pair of electrons will help for complexing it with the metal ions. So NH3 acting as a complexing agent because of the presence of lone pairs of electrons. So this reaction can be used to detect the presence of transition metals like copper and silver. Now let us see the uses of ammonia. It can be used for the manufacture of nitrogenous fertilizers like ammonium nitrate, ammonium phosphate, ammonium sulfate, etc. Also it can be used for the manufacture of nitric acid, HNO3 nitric acid, and liquid ammonia, liquid NH3 used as a refrigerant. So these are the uses of ammonia. So this is about ammonia.